In the vast, uncharted reaches of interstellar space, where the fabric of reality stretches thin and time itself seems to bend, NASA's Voyager 1 continues its solitary journey. Launched on September 5, 1977, during an era when disco anthems filled the airwaves and the internet was a distant dream, this unassuming spacecraft has defied all expectations. Designed for a modest 5-year mission to explore Jupiter and Saturn, Voyager 1 has outlived its creator's wildest ambitions, venturing over 15 billion miles from Earth to become the first human-made object to cross into interstellar space. For nearly 5 decades, it has whispered faint signals back to us, carried across the cosmic void by a dwindling power source, a radioisotope thermoelectric generator (RTG), that keeps its aging instruments alive. Its legacy is monumental, a testament to human ingenuity and our insatiable curiosity about the universe. But what if Voyager 1's most profound discovery was not in its early triumphs, stunning images of Jupiter's swirling storms or Saturn's majestic rings, but in a message received only now, after 47 years of silent drifting? In early 2022, NASA engineers detected an anomaly in the spacecraft's transmissions, a signal that defied logic, engineering, and everything we thought we knew about deep space. This was no mere glitch. It was structured, deliberate, and hauntingly unnatural. As scientists grapple with the implications, a chilling question looms. Has Voyager 1 encountered something, or someone, out there in the frozen silence beyond the heliosphere? This is the story of that mystery, a tale that could redefine humanity's place in the cosmos. To understand the weight of this anomaly, we must first revisit Voyager 1's origins. Conceived in the early 1970s as part of NASA's Voyager program, the spacecraft was one of 2 probes designed to take advantage of a rare planetary alignment that occurs once every 175 years. This alignment allowed Voyager 1 to use gravitational slingshots to catapult itself from one planet to the next, dramatically extending its mission. Launched from Cape Canaveral, Florida, aboard a Titan IIE rocket, Voyager 1's primary objectives were to study Jupiter and Saturn, capturing high-resolution images and collecting data on their atmospheres, moons, and magnetic fields. Its twin, Voyager 2, followed a similar path but with a broader itinerary that included Uranus and Neptune. Voyager 1 was equipped with a suite of scientific instruments, including cameras, spectrometers, magnetometers, and cosmic ray detectors, all powered by 3 RTGs that convert the heat from decaying plutonium-238 into electricity. These generators were expected to sustain the spacecraft's operations for about a decade, after which it would drift silently into the cosmos. But Voyager 1 was built with remarkable resilience. Its robust design, redundant systems, and meticulous engineering allowed it to continue functioning long after its planned obsolescence. By 1980, it had completed its primary mission, delivering breathtaking images of Jupiter's Great Red Spot and Saturn's intricate ring system, as well as discovering new moons and volcanic activity on Io. Rather than retiring, Voyager 1 embarked on an extended mission, propelled by its final gravitational assist from Saturn in 1980. This maneuver sent it hurtling toward the outer reaches of the solar system, where it would eventually cross the heliopause, the boundary where the solar wind gives way to the interstellar medium. On August 25, 2012, Voyager 1 officially entered interstellar space, a historic milestone that marked humanity's first foray into the galaxy beyond our sun's influence. Since then, it has continued to transmit data on cosmic rays, plasma waves, and magnetic fields, offering a glimpse into the uncharted territory of interstellar space. Aboard Voyager 1 is one of humanity's most ambitious gestures, the Golden Record, a 12-inch gold-plated copper disc designed to serve as a message to any intelligent life that might encounter the spacecraft. Conceived by a team led by astronomer Carl Sagan, the record contains a curated selection of sounds, images, and music that encapsulate the essence of Earth and its inhabitants. It includes greetings in 55 languages, natural sounds like wind and thunder, music ranging from Mozart to Chuck Berry, and 116 images depicting human culture, science, and the planet's biodiversity. Encased in an aluminum cover with instructions for playback, the record is both a time capsule and a hopeful outreach to the unknown. For decades, The golden record was seen as a symbolic gesture, a poetic act unlikely to yield a response. The odds of an extraterrestrial civilization finding and decoding the record were considered infinitesimal. Yet, it represented humanity's optimism and curiosity, a declaration that we are here, reaching out across the stars. Little did anyone suspect that the record might one day play a role in an encounter that could shake the foundations of science. In early 2022, NASA's Deep Space Network, DSN, a global array of radio antennas that communicates with distant spacecraft, picked up an unusual transmission from Voyager 1. The probe, now over 14.5 billion miles, 23.3 billion kilometers, from Earth, was sending a repetitive stream of binary data, an endless loop that baffled engineers at the Jet Propulsion Laboratory JPL in Pasadena, California. At first, they assumed it was a fault in the spacecraft's Attitude Articulation and Control System, AACS, which manages its orientation and antenna alignment. After all, Voyager 1 was 45 years old, operating in the harsh radiation and extreme cold of interstellar space, where temperatures hover near absolute zero, minus 273 degrees Celsius. But as engineers analyzed the data, the anomaly grew more perplexing. The signal wasn't random noise, as one might expect from a failing system. It had structure, a deliberate pattern that suggested intent. Most disturbingly, the data appeared to originate from a subsystem that had been dormant for decades, a backup computer that hadn't been used since the early years of the mission. Under normal circumstances, Voyager's fail-safe mechanisms would prevent such a rerouting of data. There were no error alerts, no diagnostic warnings, nothing to indicate a malfunction. It was as if the spacecraft had autonomously decided to redirect its transmissions through a long-dead system. Engineers worked tirelessly to restore normal communication, sending commands across billions of miles to reconfigure Voyager's systems. After weeks of effort, they succeeded, and the probe resumed its regular telemetry. But the incident left lingering questions. How had Voyager 1 executed a maneuver that defied its programming? And why had it chosen to transmit through a defunct subsystem? The answers, when they began to emerge, were nothing short of astonishing. As NASA's team delved deeper into the anomalous transmission, they uncovered something even more unsettling. The data stream contained energy fluctuations unlike anything previously recorded in interstellar space. Voyager's plasma wave subsystem detected oscillations in the interstellar medium, variations in plasma density and magnetic fields that didn't align with known cosmic phenomena. Embedded within these readings was a faint, rhythmic pulse, a signal that stood out against the background noise of the universe. It wasn't random. It wasn't natural. It was deliberate, almost like a heartbeat etched into the fabric of space. Initial attempts to explain the signal pointed to instrumentation degradation. Voyager's sensors, battered by decades of cosmic radiation, could be misinterpreting ambient conditions. But the data's consistency and structure challenged this hypothesis. The pulse exhibited a periodicity that suggested artificial origin, resembling what engineers call a handshake protocol, a pattern signal used to establish communication between two systems. To test this theory, NASA employed machine learning algorithms trained on decades of Voyager data to isolate irregularities. The results were staggering. The signal bore similarities to coded transmissions, as if something had intercepted Voyager's data and responded in kind. A Nobel Prize-winning physicist, brought in as a consultant, reportedly compared the signal to theoretical models of non-human communication. These models, developed in the context of the search for extraterrestrial intelligence, SETI, predict that an advanced civilization might use structured, mathematical signals to initiate contact. The implications were profound. If the signal was indeed artificial, it could represent the first evidence of extraterrestrial intelligence, a discovery that would dwarf all previous scientific achievements. As researchers continued their analysis, they made another startling discovery. By cross-referencing the 2022 anomaly with Voyager's telemetry archive, they found faint traces of similar patterns in earlier transmissions, some dating back years. These signals had been dismissed at the time as cosmic noise or instrumental artifacts, but with the benefit of hindsight and advanced AI analysis, they formed a coherent pattern, a breadcrumb trail leading to a specific region of space just beyond the heliopause. This area, previously thought to be a barren expanse of interstellar gas and dust, now appeared to host an energy field with unique properties. It pulsed, it moved, and it seemed to react subtly to Voyager's presence. The data suggested that Voyager 1 wasn't merely drifting through empty space but had entered a region where something or someone was observing it. The energy field exhibited characteristics that defied known physics, including unexplained oscillations and magnetic anomalies. Some scientists speculated that Voyager had encountered a structured phenomenon, possibly a technological construct or an artificial field generated by an advanced civilization. The idea was both thrilling and terrifying, raising questions about what else might lie hidden in the interstellar void. Perhaps the most baffling aspect of the anomaly was its temporal implications. When researchers adjusted for the Doppler shift in Voyager's transmissions, a standard correction for the spacecraft's motion relative to Earth, they noticed a discrepancy in the signal's timing. The data arrived with a delay that didn't match Voyager's expected trajectory. This wasn't a simple communication lag. Light travels at a constant speed, and the distance to Voyager was well known. The delay suggested something far stranger, a distortion in time itself. One hypothesis, cautiously floated within JPL, proposed that Voyager 1 had passed through a temporal boundary, a region where the laws of physics, particularly those governing time and causality, behave unpredictably. This idea, while speculative, was grounded in the data. Voyager's onboard clock, synchronized with atomic precision at launch, appeared to be offset by milliseconds that couldn't be explained by relativistic effects or instrumental drift. Some engineers suggested that the probe had experienced time dilation, not due to its velocity, which is negligible compared to the speed of light, but due to proximity to an unknown gravitational or energetic anomaly. This theory, if true, would have profound implications. It suggested that Voyager 1 might be reporting events that occurred in a different temporal frame. Events that had already happened, were happening now, or were yet to come. The possibility that the spacecraft had crossed a boundary where time itself was malleable challenged our understanding of the universe and raised questions about what else might be lurking beyond the heliopause. The most haunting element of the anomaly was its connection to the golden record. Buried within the anomalous signal was a frequency that matched one used to encode sections of the record. This wasn't a random coincidence. The frequency was precise, a direct reference to the record's audio signature. It was as if something had received the record's message, decoded it, and sent a response tailored to its structure. This reverse handshake suggested that an intelligence had not only intercepted Voyager's message but had understood it enough to reply in kind. The golden record contains a wealth of information about humanity, from our biology to our culture. If an extraterrestrial entity had decoded it, it would have a detailed picture of Earth and its inhabitants. The idea that something had been analyzing the record for years, perhaps decades, before choosing to respond was both exhilarating and unsettling. How long had it been observing Voyager? And why had it waited until now to make its presence known? NASA, wary of the public's reaction, has been cautious in its statements about the anomaly. Official press releases attribute the signal to possible instrumentation issues or natural cosmic phenomena, such as interactions with interstellar magnetic fields. But internal communications, some of which have been leaked to the public, reveal a different story. Scientists are deeply divided, with some advocating for a conservative interpretation and others pushing for a bolder investigation into the possibility of extraterrestrial contact. The agency has allocated additional resources to study the anomaly, including advanced AI systems to analyze the signal structure and simulations to model the energy field Voyager encountered. Collaborations with SETI researchers and theoretical physicists have intensified, as has scrutiny of the spacecraft's historical data. NASA is also preparing a public statement, expected to address the anomaly while tempering speculation. But the scientific community is abuzz with excitement and apprehension, aware that the implications of this discovery could reshape our understanding of the universe.